Thank you. Could have been anywhere in the world this afternoon, but you're here with us. So thank you very much. Who's ready for a lightning talk? Come on. All right. Here we go. In the next 580 seconds or so, here's what we're going to do, and then get some questions. So, my name is Matt Ringel. Currently unaffiliated. I have worked in network planning. I've done a bunch of network planning, network architecture, and a lot of stuff is, where do you put the stuff and why do you put it there? So there are a lot of answers to those questions, but what it means is you have to come up with answers that, you don't have to learn to tie your shoes every single time. So we're going to talk about what are the rules of thumb and the other fun facts and trivia that I use. And this is just a sampling of it because I only got a few minutes, but here we go. So, question at the top of the slide, very popular. Network planning really is technology, geography, and arithmetic. I hesitate to say math. There's very little actual math involved. But you don't always have all the information. In fact, you pretty much never have all the information. It would be nice to have KMZ files of everything. You don't. It would be nice to be able to remember the entire CIA fact book in my head. I don't. So this is about what I do and the things that I have remembered over time that typically do not change all that often. For an example here, if I asked anybody in this room, I'm not going to do it right now, the population of the Earth, I'm probably going to get 50% of you being correct. And the rest of you are going to work on data that you thought of from 5, 10, 15 years ago, because it's not particularly relevant to your lives, and you didn't refresh the data. That happens to everybody about everything. So here's a few invariants, or things that move a little bit less, that I try to work out. Ready? Here we go. First, distance and time. Biggest one, 1 millisecond round trip time is 100 kilometers in fiber. Fiber, in general, we're not going to talk about hollow core and pumping a megawatt through it and anything like that. We're just going to talk about regular fiber here. Fiber, in general, you can travel 100 kilometers, 1 millisecond round trip. This also allows you to do some sanity checks, and we'll get into that later. If you don't have KMZs, which most people don't most of the time, if you do, great, good for you. Use your favorite map directions API. If you need to find out the length of fiber cable, fiber runs on roads and railways in general. So you can use driving direct. If you're doing terrestrial run, or you're looking for a terrestrial run, you can typically just use driving directions and get a pretty good sense of where the fiber ran. And that's going to be a lot more accurate than using Great Circle over land. For example, and also, just a few numbers from the point of view of a user, right? Not straight shot, single length of fiber. New York to LA, for a user, about 80 milliseconds round trip. New York to London, 90 milliseconds round trip. I grew up in New York, I'm biased, there you go. Miami to Sao Paulo, 120 milliseconds, and that's going to come in real handy in a second. And geosync orbit, about 250 milliseconds. Speed and size. How fast do things go? Where do they go? So one thing at the previous company I dealt with, I dealt a lot with streaming video. And that meant that the coin of the realm, especially for major sporting events, was 1080p, 1080 lines, progressive scan, TV. And so that is compressed roughly 7 megabits per second with a little bit of a margin for safety. And you need that in order to keep a coherent stream without buffering and keeping faster than download. So keep that number in your head for a second. We're going to get to that in a second. Another one that I like using, 632 gigabytes. 632 gigabytes. That's a pretty random number. But what it is, it's about 1 megabit per second per month. That is, if you were running data 1 megabit per second per month constant over a line, you transfer, give or take, depending on the size of the month, 632 gigabytes. Now, if, for example, you were looking at a cloud provider who charged 9 cents per gigabyte, I'm pretty sure there's one of those, that's $56.88 per megabit second, which is a rather hilarious amount of money. But this should give you an idea of how much this data costs. Data egress from the cloud tends to be expensive, and this is very expensive. This is why the mnemonic goes, logs in, toothpicks out. And also the TCP delay equation. Show of hands, how many people are familiar with the TCP delay equation, the Mathis equation? Scattering of you, okay. So I'm not going to go into the whole thing, we totally don't have time, but what I am going to say is that if we hold packet loss to be negligible, it basically works out to saying that the amount of bandwidth you can send over a single TCP connection is, give or take, given typical maximum segment size, an inverse of your round trip time. And this is actually a pretty interesting thing to think about because, as it says here, at higher bandwidth, bits don't get faster. They just get smaller. The speed of light hates us all equally. And so, you know, it's like, hey, I got a 10 gig, great. Those first few bits, okay, but you know, the bits can't go any faster down the line. So what does this mean when we, actually, go back. And this is going to have something that's very, very interesting when we talk about what's actually possible. And to do that, we have to take a look at the physical lay of the land. Places. In the United States, you have the big 9 peering cities. New York, Ashburn, Miami, Chicago, Dallas, Seattle, San Jose, not San Francisco, and Los Angeles. These are the way they were because historically they were where railways went, in the case of Atlanta, telegraph lines went, in the case of New York. That's why the Western Union Building is the Western Union Building. The seat of government, oh, I don't know, Washington. Major commerce hubs, et cetera, et cetera, et cetera. People occasionally talk about Denver. The tricky part is Denver's not that big a city, and that a lot of westbound cable goes through there to pass the Rockies, but otherwise there's not much of a nexus of traffic there per se. But Portland, Oregon, which is a smaller city, is interesting because a lot of trans-Pacific cables actually land there at Hillsborough. And so even if Seattle is only 3 milliseconds away, being in Portland suddenly becomes something that might be more interesting. So I have no advocacy for any particular area, but that's just the reality of the surroundings. In terms of places, here's another thing that strikes people as weird. People think of South America as south of North America, and that's only kinda true. South America is actually very, very southeast of North America. You know, Sao Paulo, 2 time zones east. This is also why, if you take a look at those 2 green circles, why fiber from Miami to Rio or Sao Paulo is such a schlep. That's 120 milliseconds round trip time. So let's skip over this middle point here. Let's put that together. What I tell you about the TCP delay equation, right? It's inversely proportional to round trip time. You cannot get a 7 megabit second single stream TCP, let's say for a live event where you don't get the chance to parallelize because the event's happening when the event's happening. You can't get it from Miami to Sao Paulo. You have to serve it from closer. The most you can hope for is about 4 to 5 megabits per second. 480p is fine, 720p might be okay. Other things that happen is you get to do sanity checks on point-to-point fiber connections. If it's 1200 clicks, 12 milliseconds is theoretical lower limit, but what does that also mean? Getting quoted 7 milliseconds means they've labeled something wrong. I've had someone label the wrong Washington at least a couple of times. But also it means that getting quoted 30 milliseconds means you get to say, you've got to be kidding me. And a lot about having these numbers in your heads, the great secret of all of this, is that having the numbers first in a conversation allows you to control the conversation, allows you to get better, and allows you to have more leverage in negotiations. This is the reason I have a 4-function Casio next to my desk. Same reason. So, that all being said, I just gave you a lot of answers. And you probably have a lot of questions. I will note that, so does anybody have any questions? I will note that questions end in a question mark. Hearing none, thank you very, very much for your time.
Hey, actually, one quick question, Matt.
Oh, of course.
I liked it a lot. Do you think you could do it with like, footnotes and stuff? It's Tony from Comcast.
Oh, yeah. Hello, Tony from Comcast.
So to put, references, citable things so that people are like, well, where'd you get that? And you have something to.
I'd be glad to edit those slides and give them to the committee and set that up.
Thanks.
Quick one, you talk about satellite as well, right? But you didn't mention the TCP, EC, maybe proxy or something like that?
So I didn't mention that. What I did mention, I mean, I can't do the numbers in my head, but you're talking 250 milliseconds. So, okay, let's run it. 250 milliseconds, which is roughly double 120 milliseconds. So you're talking maybe 2 to 3 megabits.
Yeah, but you can send like EC. That's like proxy, right?
You can do selective ACK. You can say, hey, I'll just send quick and roll my own error encoding. There's stuff you can do, but in the general case, this is more about, once again, rules of thumb.
Yep.
There are things you can do, clearly.
Yep. Thank you.
Chris Whitfield, I3D. Since you mentioned Sao Paulo, I'll throw in an anecdote of my own.
All right.
Do not try to accelerate all of South America by putting a pop in Sao Paulo.
Oh God, don't do that.
There's this thing called the Andes.
Andy, and Andy, yes.
That fiber does not pass. So west coast of South America to the east coast will go through Miami most of the time.
So I will interject a rejoinder to your remark, which I will take as a question because I like it.
It was a statement.
It was a statement this one time. So there is actually one of the places. So if you go down from Sao Paulo and then all the way down the coast and you hit Porto Alegre at some point, then you hit Buenos Aires, and then you head west through Mendoza. Eventually, if you keep going west, there is actually a couple of tunnels where there's a significant amount of fiber crosses the Andes to actually get into Santiago.
Oh.
So you can do it. I've heard this is not a place for vendors. There are vendors who actually have that fiber run because that's kind of the narrowest place in the Andes closest to Santiago in order to get there. But yes, do not serve all of South America from Santiago. It will make everybody cry. I totally agree. Any other questions? Yeah, sure. All right, thank you very much.